Hello, I'm going to take you through the high-level specifications of the 6 Series B MSO. With high bandwidth, fast sampling, and low noise contribution, it's great for validating and debugging designs with gigahertz clocks and gigabit data rates. The 6 Series is available with 6 bandwidths, ranging from 1 to 10 gigahertz. Mine is a 10 gigahertz instrument. Bandwidth can be upgraded to any level at any time without returning it to service. They come in 4, 6, or 8 channel versions. To get even more visibility, any channel can be converted to 8 digital channels by attaching a logic probe. Thanks to its 4 custom Tektronix ASICs, the 6 Series offers scalable sampling. For most troubleshooting, it offers 25 gigasamples per second on 4 channels, and 12.5 gigasamples per second on up to 8 channels. For maximum time resolution and the lowest possible noise, turn on 2 channels and get 50 gigasamples per second. High vertical resolution lets you really dive into your signals. I'm connected to a bursty signal, and I'm using a visual trigger with a keep-out area to stabilize it. The Tektronix ASICs deliver 12 bits of vertical resolution for excellent detail. What I'm most interested in is seeing what's happening just before the burst. By turning on high-res mode, you can go up to 16 bits. This takes advantage of oversampling while controlling noise through advanced filtering. The Tektronix also deliver outstanding noise performance, and they're paired with the Tech61 custom preamps to deliver low noise at all volts per division settings, enabling you to see fine signal details like never before. A range of record lengths are available, from standard record length of 62.5 million points up to a billion points. Record length can be upgraded at any time. The 6 Series is more than a high-performance oscilloscope. It integrates the functions of multiple instruments. Adding logic probes enables logic channels in groups of 8, like a logic analyzer. An optional integrated function generator can output standard and arbitrary signals. It can easily perform spectrum analysis, but unlike most spectrum analyzers, it can do it in sync with waveforms and on multiple channels. It also integrates the functions of protocol analyzers, digital voltmeters, frequency counters, and frequency response analyzers. A wide range of probes are compatible with the Tech VPI probe interface, including tri-mode probes up to 10 GHz, optically isolated differential probes, single-ended active probes, differential probes, and current probes. You can use the 6 Series without installing Windows, or if you want to run PC applications or automated testing on the scope, you can add a Windows operating system. It's one of the few instruments that allow this flexibility. The 15.6-inch high-definition pinch and swipe touchscreen actually makes the 6 Series pretty fun to use. Directly position and scale waveforms. Quickly turn on more channels. The knobs make it easy to dial in your settings. Each waveform and control object gets its own badge. I can change settings by double tapping on the readouts. I can change the order of waveforms, or combine waveforms into groups, or turn waveforms off altogether by simply flicking their badge off the display. Documenting information in the display is easier than ever. Simply add a callout and choose between text, a box, or a box and arrow. There's also a special callout called a bookmark that rides on the waveform and continuously shows the measurement value at that location. You can have as many bookmarks as you want to indicate the measurements at critical locations in time or frequency. The 6 Series is outstanding at analysis. I'll start with cursors. The cursors ride along the waveform with both X and Y readouts as well as a delta readout. The cursors can easily be moved using the touchscreen or the multi-purpose front panel controls. If I want to make an automated measurement, I just drag and drop. I'll add a few measurements to channel 1, amplitude, peak-to-peak voltage, and rise time. Each measurement includes statistics to help you get a handle on long-term variation. The badge shows min, max, and standard deviation. I can jump from measurement to measurement, or quickly find the maximum or the minimum measurement. Results tables provide even more insight into the measurements and their variation. A results table provides two sets of statistics. The columns on the left show the mean, min, max, standard deviation, and population for the measurements on the current acquisition. The columns on the right show the accumulated statistics on all measurements made over all acquisitions. You can quickly see the behavior of a measurement over tens of cycles or millions of cycles. I can also look at a measurement's behavior through a single acquisition as a trend plot. The measurement trend shows values for the measurement, in this case rise time, as it varies throughout the acquisition. You can also look at the histogram of a measurement to see if there are any values that happen more often than others. Today's designs depend on fast, reliable data transfers, and the 6 Series can help you address more buses and faster buses with strict signal integrity requirements. You can add decoding for more than 20 serial protocols covering a wide range of industries and applications. Setting up a serial bus generally involves identifying the signals and setting the voltage thresholds. The bus display shows the start frame, address, data, and any error conditions. Especially for higher speed standards, to help you make sure buses meet industry standards, test automation software can walk you through connections, handle instrument control, compare measurements to the standard, and generate comprehensive reports. Automated compliance testing solutions are available for many common industry standards. Every 6 Series comes with TIE measurements and phase noise measurements. The advanced jitter analysis option includes a super quick jitter summary to quantify jitter on important clocks and data lines. It provides additional tools to help you take jitter apart and determine its sources. Spectrum analysis on the 6 Series B is much more capable than a typical scope FFT. It offers many of the benefits of a spectrum analyzer, but with some key advantages over those too. This board has a spread spectrum clock. With a center frequency of 98.5 MHz, so I'm going to punch that in, along with a span of 10 MHz, using the spectrum analyzer controls. Unlike typical scope FFT controls, the spectrum controls and the time domain controls are completely independent. Digital down converters are independent of time domain sampling. This lets you change the sampling rate and get better time resolution without affecting the spectrum at all. Unlike most spectrum analyzers, the 6 Series lets you look at spectrums on more than one channel. This board has a second single frequency clock running at 40 MHz. I can even set different center frequencies. Let's look at the magnitude and the frequency of the spread spectrum clock as they vary over time. I can trigger on the frequency or magnitude of an RF signal. I'll set the scope to trigger when the magnitude of the spread spectrum clock transitions to more than 1 volt. Okay, now let's see what happens when I power cycle the board. The time domain and frequency domain information are synchronized. I can quickly scan through the startup sequence. I can see that there's oscillation on the spread spectrum clock right around the center frequency, but well before the modulation kicks in. The 40 MHz clock comes up around 6 milliseconds before the spread spectrum clock stabilizes. This multi-domain, multi-channel view is an extraordinary capability of this instrument. With its low noise, high channel count, and high vertical resolution, the 6 Series is ideal for analyzing power rails. This power rail probe is connected to a 1.8 volt power rail right on the output of a PMIC. And this probe is connected to a 1.5 volt supply for a DDR memory module. The power rail probes let me dial in and offset so I can really focus on the ripple. Then I can zoom in on the ripple and take a look at the AC RMS voltage. With the low noise contribution of the scope and probes, I can be confident I'm looking at noise on the power distribution network. For digging into power converters, special power measurement and analysis software offers AC line measurements, harmonics, switching loss measurements, magnetics analysis, Bode plots, PSRR, and impedance measurements. Low noise, high channel count, and compatibility with optically isolated probes makes the 6 Series great for looking at complex power topologies, especially the latest converters using SiC and GaN switching. In this measurement, we're looking at conversion efficiency. With 8 channels, you can measure the total efficiency of a supply with 1 input and 3 outputs in a single measurement. For analyzing 3-phase systems, the inverters, motors, and drives measurement package greatly simplifies measurements. Make 3-phase power and power quality measurements, analyze harmonics, and on an 8-channel instrument, you can measure efficiency using the 2-watt meter method. Phasor diagrams show currents and voltages at a glance to help verify your connections or quickly spot imbalances. And most importantly, the package lets you make stable power measurements on tricky 3-phase PWM waveforms. With low noise and up to 8 channels, the 6 Series B MSO is ideal for analyzing power rails, power supplies, and power converters of all kinds. And for all your high-performance debugging and validation, more bandwidth, more channels, and less noise give you the capabilities and confidence to keep all your designs on track.